Welcome friends. In this tutorial, we will learn about quicksort. Given an array of n elements, if array only contains one element, then return. Else, pick one element to use a pivot. Partition elements into two sub-arrays, elements less than or equal to pivot and elements greater than pivot. Quicksort the two sub-arrays and return the results. Let us see an example. We are given an array of n integers to sort. There are a number of ways to pick the pivot element. In this example, we will use the first element in the array. So we are considering the pivot element as 40. Given a pivot partition, the elements of the array such that resulting array consists of one sub-array that contains elements greater or equal to pivot, another sub-array that contains elements less than pivot. The sub-arrays are stored in the original data array. Partitioning loops through swapping elements below or above pivot. So now the too big index is 1 and too small index is 8. Step 1. While data of too big index is less or equal to data of pivot, then increment too big index. So the too big index is incremented and then again it is incremented, but 80 is greater than 40, so the loop will terminate. Now second step, while data of too small index is greater than data of pivot, then decrement too small index. So too small index will be decremented. But now 30 is smaller than 40, so no decrement will take place and now the loop will terminate. Third step, if the too big index is less than too small index, then swap data of too big index and data of too small index. So 30 and 80 will be swapped. Fourth step, while too small index is greater than too big index, then go to step 1. Now again this function is called, so the steps will be performed again. Now 40 is compared, so the following steps take place. Now the data is swapped and so 7 is placed at its correct position and pivot index is 4 at the end. So now we have the data partitioned into two parts, that is data which is less than data of pivot and data which is greater than data of pivot. Now quicksort analysis. Assume that the keys are random and uniformly distributed, then the best case running time is O n log n to the base 2. The worst case running time, we have recursion. Number 1. Partition splits array in two sub-arrays, one sub-array of size 0 and the other sub-array of size n-1. 2. Quicksort each sub-array. Depth of the recursion tree is O n. Number of access per partition is O n. Thank you for watching the tutorial.